Hey everyone, so today we're going to move on from graphing to simplifying square roots and also nth roots. Alright, so pause the video and try this SAT problem. Horsepower and watts are units of measure of power. They are directly proportional, such that 5 horsepower is equal to 3730 watts. How much power in watts is equal to 2 horsepower? So when I see directly proportional, I think x over y equals x over y. So 5 over 3730 equals, the 5 is the horsepower, so that goes on top, so 2 goes on top. So cross multiply, 5x equals 7460, divide both sides by 5. And I get 1492. Columbus sailed the ocean blue. That's it. Now, you probably didn't do it the way I did it. Most kids just say, oh, 3730 divided by 5 times 2. You can kind of just logically figure it out. But whenever direct proportional is a fraction equaling a fraction. All right, what does it mean to simplify a square root? So we've been doing this throughout the year, so we're just going to make it a little harder today. So that's rewriting a square root. So there is no perfect square that is a factor. See, I wrote that wrong. It's a perfect square. I have factor too many times. A perfect square that is a factor of the radicand. The radicand is just the number under the square root. All right, number under the square root. Right. So, for example, the square root of 12, right? We simplify that because 4 goes into 12. 4 is a perfect square that is a factor of 12, right? All right, so do these two. Again, this should be a review. This should be pretty quick. So pause the video. So 63 is 9 times 7. Right? Square root of 9, square root of 7. Square root of 9 is 3. We don't know the square root of 7, so we leave it. Number 2, now be careful here because you have 16 and 5, which is the answer, but then you have 4 and 20. So if you use 4 and 20, be careful because that's not right. So you get 5 and then the square root of 16, the square root of 5. Remember when things are touching, that's multiplication. So 5 times 4, so we get 20 root 5. Now, if you did the 4 and the 20, you would end up with 10 root 20. But if you look, what perfect square goes into 20? 4. All right, 4 and 5. So you get 2 root 5 and then 2 times 10. So you do get there eventually. You just might have to take a couple extra steps. So just be careful because 20 does have a perfect square. All right, pause the video and do these. All right, square root of 121 is 11. So again, this is multiplication. Negative 33. All right, don't get too, use your logic. Someone in my class, a lot of kids, they mess up things like 500. They're like, oh, that's a multiple of 25. But 25 is not the biggest, right? It's actually 5 and 100. So I'm going to write it backwards, right? 105, square root of 100 is 10. And then times that 15, 150 root 5. Again, if you did 25, it would be $5 has 20 quarters in it. So it would end up being 75 root 20. But then again, you can pull, just like before with a 20, you can pull out another 4. Okay, so now what if we had variables? So this is the new stuff. What times itself is x squared? X. Now, there's a caveat to this. I've never actually used that in real life. The caveat is, technically, this is the absolute value, right? Because if you plug a negative into x, like negative 3, that square will make it positive 9, and then you get 3. So it's actually not x, it's the absolute value. We're going to kind of ignore this, though. This will come up later in the year. It comes up in calculus. So that is an important fact to remember. But we're not really dealing with functions here. We're dealing with expressions, so we're not going to make it a big deal. All right, so what would be the square root of x to the 6th? What times itself is x to the 6th? X cubed. Another way to think about this, remember this is a 2 and this is a 2. So when we rewrite it as a fractional exponent, remember that the exponent's on top, the root is a 2. 2 divided by 2 is 1. 6 over 2 is 3. So that's another way to think about it if that helps. So the even ones are easy. What's more difficult is the odds. So we need to simplify this because there is a perfect square that goes in x cubed. What perfect square goes in there? 2. So if we could rewrite this as x squared times x to the 1st, right? 2, we're basically going backwards. 2 plus 1 is 3. The square root of x squared is x, and then that x is stuck underneath. Similarly, what perfect square is just under 11? What perfect square, not my brain stopped working. How can you simplify x to the 11th? You need an even number, right? What's the biggest even number that's less than 11? 10. So this is really x to the 10th times x, because x to the 10th, you just divide by 2 and get 5, right? X to the 5th times x to the 5th. All right? So basically you just go down by 1, and then you're able to then divide by 2, right? Because you have x to the 10 over 2, x to the 1/2. You can't simplify that 1/2, but 10 over 2 is 5. All right, so pause the video and try these. So this first one is pretty easy. So 64, the square root of 64 is 8. The square root of x to the 4th, we just divide by 2. It's not the square root of 4. It's 4 divided by 2, even though they're the same number. All right, square root of 25 is 5. So then how are we going to do x to the 7th? So we needed the biggest even number under it. So half of x to the 6th, right? X cubed times x cubed is x to the 6th. And then we have that leftover x on the inside. All right, so 40. And a lot of times it makes it easier if we break this apart like this. So 40 is 4 times 10. X to the 7th, x to the 6th times x. So the square root of 4 is 2 root 10. And then the square root of x to the 6th is x cubed root x. And then don't forget, after we put that, we got to smush them back together. Or combine them is the more appropriate term. But I like the word smush. It makes me happy. And then 10x. So that would be our final answer. All right, last one. So the square root of 18 is 9 times 2. That's 3 root 2. Square root of 9 is 3. And then what about that square root of x to the 8th? X to the 4th times x to the 4th is x to the 8th. And then we put that with the 3. So 3x to the 4th root 2. Done. All right, pause. Try this one on your own. So I've got my 125, which is 25 times 5, right? 5 quarters gives me 25. X cubed is x squared times x, right? I need that even. And then y to the 15th is y 14 times y. So I'm going to take the square root. Square root of 25 is 5. So we're done with that. Square root of x squared is x. Square root of y to the 14th is y to the 7th. Everything else is stuck inside. The next one, again, is a little tricky because it's got that, it's got a bigger number, right? So play around with the numbers. What perfect square goes in a 288. It's 144 times 2, right? And then we have x to the 8th and y to the to the 23rd is y to the 22nd times y. Right, the 8 is even, so we don't have to worry about it. Square root of 144 is 12. That x to the 8th gives us x to the 4th. And then y to the 26th gives me y to the 11th. And then what's left inside? We have the 2 and the y. Right, so 2y. But then I did leave off my negative 8 that was in front. So we get negative 96, x to the 4th, y to the 11th, root 2y. That's it. So I would say go and work on, pause the video, and go and work on the classwork. I don't know if I'm having you do the whole thing or just part of it, but go work on the classwork now before we go on to the second half of the lesson. All right, so now we're going to look into perfect cubes, fourths, fifths, etc. So what are the perfect cubes? So look for your table. You should have a table listing them all, right, that we filled out. So those are my perfect cubes: 1, 8, 27, 64, 125, 216. Perfect fourths are these: 16, 81, 256. Perfect fifths: 1, 32, 243, and so on. Now, the only ones that I would actually expect you to remember, or the ones I can remember, are these. I'm not underlining 1 because that's just silly. The others, maybe have your list available to figure out, because other than the ones I underlined, like I don't have them memorized, it would take a little bit of time for me to figure them out. But I could, so have your list with you when you're doing these problems. Okay, so same idea, but instead of perfect square, what perfect cube goes into 24? So our perfect cube, remember 1, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd is 64, 5 to the 3rd is 125. So those are the main ones, right? So which of these numbers above, other than 1, goes into 24? That's 8 and 3. Right? So we've got the cubed root of 8 times the cubed root of 3. The cubed root of 8, what times itself 3 times is 8? 2. We can't do anything with the cubed root of 3, and we're done. All right, 135. Now that one might be a little tricky. It's not obvious when you look at it, at least not to me. That is 27. 135 divided by 27 is 5. So this is the cubed root of 27, the cubed root of 5. Cubed root of 27 is 3, so 3, the cubed root of 5. Now, how do you think we're going to do x to the 5th? So before, we did what even number is below the power. So in this case, since our root is a 3, what multiple of 3 is just under 5? So this is actually the cubed root of x cubed times x squared. Right? Because 3 over 3, right, what times itself 3 times is x cubed? X. And then we're left with 2, right? That's because the power is less than the index, you're good. So now we put these back together. So 3x, the cubed root of 5x squared. So when it's a cube root, we're looking at multiples of 3. If it was a fourth root, it would be multiples of 4. A fifth root, multiples of 5 for your variables. All right, so pause and try this one. All right, so 375 is 125 times 3. And then the cubed root of x to the 9th, now that divides nicely, right? 3 goes into 9 3 times. So there's no root left over for the x's. The cubed root of 25 is 5. The cubed root of 3. Smush those together. 5x cubed, the cubed root of 3. All right, next one. Now we got a fourth. What perfect fourth goes into 162? It is 81 and 2. And then what perfect fourth, or what number is a multiple of 4 just under 11? Right, so that's 8, right? So that's the 4th root of 8, x to the 8th, and then the 4th root of x cubed, right? 3 plus 8. The 4th root of 81 is 3 times the 4th root of 2. And then the 4th root of x to the 8th, just again, divide. 8 divided by 4 is 2, x squared. And then you're left with the 4th root of x cubed. Combine those back together. The outside numbers go together. Your inside numbers go together. So what some students in my classes are doing is they're saying, oh, well, 11 divided by 4 is 2, and there's 3 left over. So this is how many x's are on the outside, and this is the x's on the inside. So they're kind of using, kind of like that idea of I. The numerator is your outside number, and then the remainder is your inside number. That makes sense to them. I like my way, but whatever makes sense in your brain. All right, so pause and try these. So now this one's actually an easy one. The 5th root of 32 is just 2. The 5th root of x to the 5th is x, right? 5 divided by 5. And the 5th root of y to the 35th is y to the 7th, right? All of these are multiples. Those are both multiples of 5, so it goes in nicely. Ooh, 768. Let's see. 768 divided by 2, 384. That's not helpful. That's not a nice number. Let's see. Try to divide by 3. So this is 256 times 3. A to the 15th. So now I'm looking for a multiple of 4 just under 15. So that's a to the 12th times, because it goes in 3 times, right? 4 goes into 15 3 times, right? 4 times 3 is 12. And then we have 3 left over. And then our b's, b to the 24th times b. Okay. So that's how I'm breaking this down, and all of these are 4th roots, right? 4th, 4, 4, 4. Oh, that's terrible looking. 4 and 4. All right, so let's do all the outsides. The 4th root of 256 is 4. The 4th root of a to the 12th is a to the 3rd. All right, just dividing. This is hard to read, sorry. So I'm done with this guy, and then the 4th root of b to the 24th is b to the 6th. So we're done with this guy. And so all the simplifying is done, and so now I have my 4th root. And what's left? We got a 3, an a cubed, and a b. And that is your final answer. All right, last one. Pause the video, try it. All right, I had to grab my calculator. This one was a little tricky. If you have your table, it's really helpful. So 684 is 343 times 2. 343 is the cubed root of 7. Right. N to the 6th we're good with because 6 is a multiple of 3, right? Because our index is 3. And then m, we need a multiple of 3. So that would be 27, and then m to the 1st, right? So now we're doing a cube root. I'm just going to write one big cube root this time to make my life easier. So the cube root of 343 is 7. Right, so we're done with that. The cubed root of n to the 6th is n squared. The cubed root of m to the 27th is m to the 9th. All right, cube root, and then we have an 2 and an m left over. That's it. All right, now 1296 is actually a perfect fourth, right? The 4th root of 1296 is 6. Right? So we have just a 6. And then we have the 4th root of a squared and b to the 12th. So this is b. Oh, and the both b to the 12th is nice and even, right? So we have 12 divided by 4 is 3, so b cubed. And then we have the 4th root of a squared. But we can actually simplify that. Who remembers how to do a 4th root of something? Remember, that's the square root of a square root. The square root of a squared is a. So this actually simplifies down to 6b cubed times the square root of a. And that's it. All right, have a great day.